Nice to meet you all. My name is Heemskerk and I'm with Heemskerk Innovative Technology in Holland. It's a small company, high-tech. I'll introduce some of the work that we do before I introduce the work that we would like to do on Alzheimer's disease in combination with telehealth. So first, who is HIT? What does this HIT company do? Why do we want to work on Alzheimer related projects? Actually introduce the disease and what we intend to do about it, because the disease is not curable. So what else can we do? How can we help people that have the disease or start to have the disease? Heemskerk Innovative Technology supports high-tech projects, nuclear fusion, space, robotics, and robot vehicles. Really fancy high-tech stuff, but always with a robotic component. We want to move things, we want to make things work in the real world. And the last few years we've been mostly busy with nuclear fusion. It's a new area where you can make energy from seawater, basically. If you're interested, I can talk a lot about that, but it's not the topic of today. And we are not working on the device itself, we are doing the maintenance. We're doing the maintenance with robots. And because the machine gets contaminated with toxic elements and some radiation, then you don't want to handle it with your bare hands. That's why you bring in the robots. The robots are stupid, as most robots. So to make the robots work in this application, you need remote control. And that's the link to what I'm going to talk about today. The context that my company works in is really academic. Quite a few links to research institutes, universities, mostly across Europe. And just to give you an impression, some of the work that we do, in ITER we have set up this control room, which is a set of 4 working desks that mimics the setup in the ITER control room where they control all the robots. There's 12 setups like this, where teams of 3 or 4 people control a set of robots doing the work in one operating theater. It's like a surgery where you have a team of specialists, the chief surgeon, but there is also some nurses helping him to do the work. And there is remote handling control, teleoperation. For example, here we are in the hot cell, the ITER garage, where there is a part of the machine. This is about 6 meters long, 17,000 kilograms of steel with intelligence inside, mirrors, monitors, and some of these elements will wear out or they will break, so you need to replace them in remote control. So you have these small images represent real camera views. The large image, it's not a real image, it's a virtual reality image that helps you to do the work, because you cannot always put the cameras in the right place. But this is another picture of this port plug, as we call it. This is the part that is really going into the reactor, facing the plasma. But this is the most contaminated part. It needs to be taken out to get access to the mirrors that are inside. And then our job is to take the mirrors out and replace them with new mirrors. Other projects we have worked on, European Robotic Arm. It's the big European arm that's going to space station. It's still in Russia, waiting to be launched. Here, some picture in the clean room where we are testing just before it was shipped to Russia. Another example from ITER. Once again, we're in the hot cell, but now we have some animation, so things moving. What you can see in the small images is that the real cameras, these are still simulated because ITER is being built, but we have simulated the real cameras and we have simulated this artificial viewpoint. The real cameras do give you some sense of telepresence, but it's the big view that tells you what you're doing. And here we are working on some of the mirrors. These are mirrors that can move, and they are about 30 centimeters from the plasma wall. But they are really up front, will get a lot of radiation, need to be replaced. And this is one of the robots, 2 arms, controlled by telemanipulation. So there is an operator in the control room with 2 arms controlling the robots. And in the nuclear world, it's usual to work with telemanipulation, but most of that is mechanical telemanipulation. So you have 1.5 meters of concrete wall, you have a robot on the outside, mechanically connected to a copy of that robot on the inside. So when you're moving the arm on the outside, you move the arm on the inside doing the work. You get some haptic feedback, you feel what you're doing because you're mechanically connected, and you have a visual connection because you're looking through a lead glass window. So you see the actual work about 3 meters away from you. In ITER, that does not work because the objects that we are handling are quite large. Meters, and the area, the garage, is hundreds of meters, like 2-3 football fields where you need to do the work. So no way that you can do mechanical telemanipulation. So it's electrical robots doing the work, controlled by electrical robots at a distance. Another picture of a recent analysis, how you can use this technology also in early stages of development to do predictions on the maintenance. So we make this simulated environment from the CAD model, and we try the different maintenance scenarios and we see where it goes wrong, because we not only simulate the kinematic elements like you would have in a computer-aided design system, we also simulate the physics, the contact interaction. So we are able to feel what is happening in the simulation. All the objects that we simulate, they have mass, they have characteristics of the surface. So when they hit each other, you feel the interaction. When they slide, you feel the friction. And that brings a new dimension in the world of simulation. To make a parallel, you may be familiar with making nice renders from a computer drawing. But typically what you do to make a really nice picture, you put some textures on the surfaces. So if you want to make a surface look like wood, you paint the surface with a wood texture. And then you put in some lights and you render with lighting and shading. And if you want to make a movie out of that with a good feeling of reality, you need to render that maybe 20-25 frames per second. And a reasonable computer can take some time doing that. If you're really simulating water and such things, transparency, you can spend an hour on one frame. In the haptic world, we do a similar thing. When we want to feel the objects, we need to put some additional characteristics in the simulation, like the mass of the object, the friction characteristics. And then we start to feel it. The only challenge is that to make it feel right, you need to render it at about 1000 Hertz. So you need to calculate about 1000 frames per second. And we do it on a normal computer. So that's a bit of a trick, and that's quite unique. And that's the kind of technology we would also like to bring into the health telecare world. We did some other things. We developed hardware, robot. We developed other simulation software, also procedure-wise. And here is a kind of comparison. On the left-hand side, you see the simulation running. And this is a simulation where we simulate flexibility of elements. You see a cable. We simulate the mass, so the operator handling this tool is really feeling the weight of the tool. And when he's trying to insert the tool into the tube, you get this typical peg-in-hole problem. When you're not well aligned, it will get stuck. And that's all in the simulator. On the right-hand side, you see the same product that we built in hardware, aluminum and steel. And you see the same parts in the object as in the simulation. For example, connectors, bolts, pins to make it fit, some handling ears to pick up the object. I will try and rerun it. On the right hand side, we did a test with a hardware setup, which was identical to the object we simulated. And we tested it with operators in Petten, which is one of our nuclear facilities in Holland. So that's people that are experienced with telemanipulation. And we put them to the task to do the same manipulations as we simulated. So we did the simulation first as an introduction, as a teaching guideline. And the striking result was that every time we had problems in the simulation, getting stuck with the cable, cable was hooking behind another object, there was too much friction by inserting the tool in the tube. Those instances came back in the physical test. So we were not only training the operators with the simulation, we also were able to predict where they would have problems. It's a kind of validation of the simulator. One last example before we start to do Alzheimer. A medical project we worked on a couple of years ago. It's a DNA synthesizer. Totally different world. It's also high tech. It's also a bit robotic. But that's it. This is a laser writing on a microscope slide a light pattern, and where the light has hit the slide, there is an activation of a nuclear group, and the group binds to a liquid. And when you repeat that process, you can actually construct DNA on the spot, on the microscope slide, and by programming the laser beam to have a different spot pattern every layer, you create hundreds or thousands of different DNA strands in the different spots. It's an instrument that you can use in the analysis of DNA samples, so it's a laboratory instrument. Now, the link to Alzheimer is this project we are about to start. It's called haptic human interaction system. It's a teleoperated robot. Link to the nuclear work that we do. This is the picture of the actual robot that we're going to use. It's a Spanish robot. It's real, it's existing, it's for sale. It's about 100,000 euros. If you have some money to spare, you can buy it. It's a wheeled robot. They also have a newer variant, which is walking. And it's really nice. It's like Asimo. You know Asimo, I think. It's Asimo, but a little bit better, and it's for sale. Only the mobile robot, the walking robot, it's like 500,000. And it will last maybe half an hour on its battery, so that's not interesting for a practical application. So we stay with the wheeled version. It has the same torso as the walking robot, so it can have a real interaction with people. It can lift up to 10 kilograms with 2 arms combined, or 1 kilogram with a stretched arm. So it can go into the kitchen, open the fridge, take out a bottle of milk, pour the milk in a glass and bring it to a patient. That's the kind of support activities we imagine. It's a robot. That means the robot is automatic. You can pre-program it. Once you train the robot, it will be able to find the way to the kitchen. And with a little bit more training, you can even learn it to recognize the fridge and how to open the door. But when the milk is on the wrong shelf, it will still have problems finding the milk. Or if it's a different type of milk, a different brand, so the carton or the bottle looks different. There is a gray area where you could pre-program the robot, but it takes a lot of effort to train the robot. And our idea is not to automate everything up front, so we have a basic repertoire of skills, basic navigation skills, not bump into the wheelchair or not bump into the table, that kind of basic element. And all the rest we train on the fly, because this robot will be at home with a patient, and it will be in a new home every couple of months. So it's impossible to train it on beforehand in a generic way. But by adding teleoperation to it, this haptic workstation, and that's the same type of haptic workstation we are building for the nuclear industry, a nurse at a distance can step in for those jobs that are a little bit too difficult for the robot. Not too difficult in the physical sense, but in the smart sense. That's why I keep repeating robots are stupid, and we have to help the robots to become smarter. So we have to train them. And with this haptic interaction, you can do it. You can also do it with just a joystick. We have seen that in different experiments with healthcare robots in Holland. When you use a joystick, you can do the job, but it will take somewhere between 10 and 20 times as long as you would do it in a natural way. If you use a haptic interface, a robot arm, and the robot arm at a distance copies your motions, it's between a factor 1 and 2. So it's a slight overhead, but you save a lot of time because the nurse is not traveling. And maybe in Holland travel time is between patients half an hour or something like that. I can imagine in Finland, in the remote areas, travel time for a nurse could be half a day. So, and this really makes a difference. So, now we make the big step to Alzheimer's disease. Why would this work for Alzheimer's disease? I'm wondering, who of you has a relative with Alzheimer's disease? 1, 2, 3, 4. I predicted there would be 5, but yeah, 5. But maybe you can tell a little bit about your relative?
Yeah, that's my mother. She has been in an institute already 7 years, and the symptoms were evident maybe at least 2 years. She could be home with somebody visiting there and living periodically in our house and so forth. And I have followed very close by weekly her life and the life of many other patients who are there. So
Do you remember the early stages where there was this phase where she still was able to live at home, but things went wrong?
Yes, very well.
And there was always a risk of things going wrong in a terrible way.
Yes, a little bit.
And
Yeah.
do you think that if there would be a companion in the house, even if it's a robot, that it could help?
I'm not quite sure.
What,
Yes.
what would that robot need to do to make it work?
I mean that, for example, in her case, she has never been very flexible with adapting new type of technology, for example. Not even a mobile phone, when I thought that it had been handy for her. So, and I think that, yeah, difficult to say. Difficult to say.
The ease of use should be
Of course, natural.
extremely important.
Natural, yes. But when these type of persons, when they start to like close their word, you know, there is a long list of symptoms that people don't like to contact with any new persons. They don't want to travel. They don't want to go away from their home. They want to see all the things on the same dinner table, and I could not touch there and clean it. She wanted to have it exactly as it was. If light bulb was broken, the package was there, so that she remind her to buy a new one, and so on. And so the life comes very, very limited.
Thank you.
And routines are very, very important.
I hope there are some more stories. Maybe you?
Yeah, both my grandmothers had Alzheimer's disease. One of them is in an, you know, and the other one is my grandfather is caring for her. But yeah, it's getting worse and worse, and they do remember me, but I think in a year or something they don't remember me anymore.
That's the problem. The disease is progressive. It doesn't get better, it only gets worse. At some point in time you're happy when they think you are your brother, because then you're still family. They give you the wrong name, but they still recognize something.
Yeah.
And, but where I'm aiming at is the really early stages. So, it's quite a common disease. Estimates are that there is going to be 1 in 20 people over 80 that's going to have to deal with this disease. On the total population, it could be 1 in 85 in some time. The name of the disease was described by a doctor, Austrian doctor, Alois Alzheimer. So it's about 100 years ago that he first described the symptoms. And there is this increasing risk with age, but there is also a distinct group of people of a much younger age, around 50, that already have the symptoms. And this is a picture how the brain is affected. You really see a deterioration. You see big holes, and that's how people think of the disease. You have holes in your brain, but also it's the processing, the motor skills, the recognition skills, and the hippocampus, the emotional side that is being affected. So indeed, people tend to get retract themselves in a much smaller environment. In some ways it's like autism, when people do not want to have new things to be exposed to, but it's also not being comfortable in other than the really strict known situations. There's only one big misunderstanding about Alzheimer, and that is that people with the disease are not able to learn anymore. That has been proven a couple of years ago, that people even with the disease are able to learn new things. It is very difficult, it takes time, but they still can learn. So if they feel comfortable with a new solution, especially when it's a kind of a trick to help them remember in the new environment, for example in the care home where they are now living, how to find their way through the corridor just by remembering a picture, they can still learn it. Problems. Yeah.
May I just ask something between?
Yeah.
If they can learn, can they as well learn things they've taught? Which means the early stages.
I'm not an expert, so I'm not certain about how well they can relearn forgotten things. What I do know from practical situations is that when they are moved into a new environment, forced, because they are not able to live at home anymore, they can adjust to that new environment. So learn their way through a corridor. But usually when they are taken up in a home, you need to close the door at the end of the corridor, because when they wander outside, they will get lost. So maybe that's one area of apps we can think about, is navigation help. But the point is that the interface to that navigation help should be so intuitive that they are able to learn that. So when we think about a tablet and an app on a tablet, when they have even never used a mobile phone, there will be a challenge in learning them to use that. So you have to start a little bit earlier. So when the symptoms are appearing and people still live at home, you have to train them in using a new system and get them used to working with the system. That's the way you can help them to stay at home a bit longer and be self-supporting. And they may have to learn some new tricks to do that. The early symptoms, it's not just memory. It's orienting. The internal GPS is failing. The finding the right words. Sometimes the language is the first that you notice. People are looking for not only the names of persons, but they fail to recognize that they know the person. It's a little bit more to that. The emotions also change. The hippocampus is affected. Making decisions becomes more difficult. So putting alternatives in a structure, making a decision is more difficult. Handling money, just counting money is a problem. And
if I may add here that it is usually, according to some research, that patients in average, because this is very, very personal as well, have had like the biological changes and the Alzheimer's disease 4 years already. I mean the physiological changes before it is like detected by the relatives or family members or physicians and so on. So the very weak signals should be looked very carefully, because when the medication then, which will not make anybody healthy, but it will slow down on the development of the disease, when it will start it, the soonest it will start it, the better it is.
So there is a very difficult time for the patients, because they have symptoms and they don't know what it is.
And they try to hide them automatically as well.
But at the point where they start to fail in their job, they start to make so many wrong turns driving the car, make mistakes with counting money, so they only use PIN, or credit card, because they fail to recognize the amount of change that they have to expect. There is this critical point where the patient feels relieved with the diagnosis, so that they know they have Alzheimer's. So there is a rational explanation for them to feel so strange and for them to behave in such a strange way, to lose your spouse because of it, or sometimes it's one way around or the other way around, and it can be a very difficult situation. By the time you get the diagnosis, usually the patient is still fit enough to live at home by himself or by herself. And that's the time frame I think is most interesting. So around the time that the diagnosis is being made, and you can still do some treatment with medicine, not to cure, but to delay. You would like to monitor the progression of the disease, because if it's going in a steep way, you may want to change the medication. If it's going really flat, you may allow the patient to do some other new things by himself. And it's much more than forgetting things. It's really getting lost in things of daily life, the procedures, the people you work with. And it's that area that I would like to target with solutions. If we can help the patients, train them to maintain basic skills of daily life. So it's quite a change in mindset. We are not training the memory alone. So there are already apps to do memory on a tablet, so people can use that. Going back to the demographics, this problem is going to increase. By the time Rob and I are 80 years old, about 30 years from now, we may be eligible for care. So the kind of solutions that we would like to aim for are the solutions that will help us in 30 years.
You have to build and to take care for our care later on.
Exactly.
20 to
So
30 years.
you can choose. You have to either wash our bottoms or you develop a robot with us to do that. And there is also an economic factor. Putting a patient in a home is extremely expensive. Depending on the country, in Europe, it's somewhere between 5,000 and 15,000 euros per month. So you can imagine that a simple tablet application or even a robotic application will pay back quite quickly for itself. If you can prove that you can keep people out of a home for 1, 2, 3 months. The way we would like to approach it, and that's the for some of the teams working these weeks, it's in their assignment, is to develop a kind of interactive game to train and to monitor the skill of the patient. And the way we would like to do it is to stimulate different senses, so, and different skills. And not just memory games, but combination of skill games inspired by the activities of average days. And in Holland, with the 3 teams from Holland, I already did some exercise like this, inspired by a list on the Alzheimer website. It's in Dutch, but we can translate it if you want it. The message is the training should be based on really normal, everyday activities. That's useful. I think one of the teams is working on counting money.
Well, we were, but until yesterday.
Okay, well, that would be one good idea. Feeding the fish is still in?
Yeah.
Okay. But let's do one. Watering the plants. What can you imagine? How would you create something with watering the plants? And how could it practice some basic skills?
Build a robot so grandma doesn't have to water them.
You could do that, but that would not train grandma. Now, what could work is, for example, put, I don't know what the word is, heater? Heater? The container you use to water the plants, maybe I have Alzheimer, I don't remember the word.
Watering can.
A watering can.
In Dutch it's called gieter, but it's easier.
People from the UK, what's the name for it? A can with
Watering can.
a watering can. That's the right word? Okay.
can also
Right. So if we would instrument a watering can with a motion sensor, we could really do the motion of watering a plant. And perhaps on the screen of the tablet, scroll a couple of plants. Some of them dry, and some of them still good. So you would give them a different dose of water. And when you have a dry plant and you pour the water, you see the plant reviving. That could be a way of doing it. So you basically train the skill. And I hope we can do some of these exercises during this week. Any other ideas? Because the subjects are chosen, I understand already. Did you see Feeding the Fish, the presentation already? You did? Did the team get feedback on that presentation already? Was it a one-way? Guys from Holland who did the presentation?
That would be me.
Yeah.
We didn't get feedback yet. We only showed the demo and explained a bit about it. So
I'm wondering about the reaction from the general audience. How can you make feeding the fish more interesting? Think about the skills that you want to train, or think about the monitoring. No ideas? Imagine you are a doctor, and it's your patient that is being trained with the feeding the fish game. Why would you, as a doctor, want the patient to use the game? What would you get out of it?
Would monitor the performance of the patient potentially. So if there was different levels, you know, and if the patient can't do level 3 and he can do level 1, that kind of already sets the benchmark.
Yeah.
You know, in terms of the progression or non-progression in that case.
So if you repeat the game after a week and you only get to level 2, you start to wonder. And if the week after you only get to level 1, then you start to worry.
Yeah.
I think that would be a good one. Is that in the game, guys? Levels?
No, not yet.
Okay. Can you imagine levels in the game?
Well,
Making things more difficult?
yeah.
Different kind of food for different kind of fish and so on.
Or adding the numbers.
So that means you put some cognition aspect in the game. Okay. So it's not a level, but it's a different aspect that you would monitor. I think that's an excellent idea. So that's the kind of thinking I want to stimulate. When you work on the Alzheimer projects, keep that in mind, that you want to take something from it, from the perspective of the patient, from the perspective of the nurse, from the perspective of the doctor, and maybe you can think of some other perspectives, and we will try and train that in Scrum sessions later on.
Isn't it important to keep all the senses active? Because if you have a tablet game, you only keep your mind and your finger active, but you don't keep active like any other senses.
How do you for real like fish feed a fish?
Yeah, you keep forgetting like the hearing thing and smelling thing and all the others.
I think in the end it needs to be multisensory, because the basic emotions are multisensory. If you are far away in progression of the disease, the only thing that may comfort you is a room with dim lights, soft music, a nice smell, so you feel comfortable without any need to make a decision or any action. But that's at the far spectrum of the disease. In the early stages, it's combinations of memory, cognition, but including the different senses and the different skills. So it would help if you could add more input aspects and more feedback aspects. But that's why I would like to introduce the motion sensing in the game area. Any other questions? And this is the introduction for now on the disease. Feel free to approach me later.